multiple x's, do you work, like, on one of the exam reviews, when I was solving for it, the answers, it was just like, we just put them into like inequality form, but it didn't have any reasons, like, there was one, it was like between 4 and something else, but then when you solve it, it's not how.
It would help if you could give me the problem.
Yeah, I'll show you.
Which exam review is it?
One, it's like very basic, but like, I'll show you. So here, when I factored it and I got x minus x plus 3.
Well, let's just walk through it, okay? So it's x cubed, right? So it's x cubed
minus 3x squared minus 18x is greater than or equal to 0.
Okay. And so you gotta find all the numbers you can put in for x that make the left-hand side greater than or equal to 0, right? So immediately, you see that this factors, right? You can factor out x, right? You got 3 terms, x is in each term, and the lowest power of x is x to the first. So we can factor out an x, so we have x times x squared minus 3x minus 18 is greater than or equal to 0, right?
Yeah, I got that, but then like, the answer was way different from, it didn't make any sense with the solutions to this.
Okay, so then this factors, right? So we have x times x minus 6 times x plus 3 is greater than or equal to 0, right? And then you gotta find the zeros of the left-hand side, right? So x equals 0, x equals 6, x equals negative 3, right? Then you use those to split up the real number line into intervals. So what do we have? Minus 3, 0, and 6. And since our inequality is greater than or equal to, we know all 3 of those numbers are in our solution set.
Wait, but negative 3 isn't equal to, is less than 0.
No. I mean, yeah, negative 3 on the real number line is less than 0. That's how I've got it plotted.
Yeah, so how can you say that that works in the equation?
Well, you put negative 3 in for x up here, and the left-hand side of this, left-hand side equals 0. So negative 3 is part of our solution. I think you're misunderstanding or confusing, right? All the x's don't have to be greater than or equal to 0, right? Just the value of the left-hand side has to be greater than or equal to 0.
Okay.
If I put in minus 3 in for x, and minus 3 cubed minus 3 times minus 3 squared minus 18 times minus 3. Minus 3 cubed is minus 27. So minus 3 squared is 9. 9 times minus 3 is minus 27. And minus 18 times minus 3 is plus 54. That equals 0. So minus 3 put in for x up here makes the left-hand side equal to 0. Okay? It's the value of the left-hand side that has to be greater than or equal to 0.
Okay.
Not the values of x. Okay? Does that now address your question?
Yeah, it does.
Okay. All right. Next.
Is that the finished, like, is that the final answer?
No, now you gotta do test point method for each of these intervals, okay? So, if we did a test point for this one, right? And you just gotta see whether it's, the left-hand side is positive or negative, Okay.
And you want it to be positive, right?
Want it to be positive because it's greater than. So if we use the factored version here, right? And you put in -4. So let's just write it out. So we got 1, 2, 3, 4 intervals. The first one goes from -infinity to -3. And we use -4 as a test point. When you put -4, right, using the factored form on the left-hand side, right, you have -4 times -10 times -1. You have a product of 3 negative numbers, which is negative. Right? That's all that you're concerned about, right? When you put in -4, does the left-hand side equal a positive number or a negative number? Okay. And so we have negative times negative times negative, which is negative. So any real number less than -3.
Wait, if you put it into the other one, like what you did with the -3,
Yeah.
wouldn't it be positive?
No. Because you'd have -4 cubed -3 times -4 squared -18 times -4. -4 cubed is -64. -4 squared is 16. 16 times -3 is -48? And then -18 times -4 is what? +72.
Okay.
-64 -48 is what? -112. So what is this? -40? That's a negative number. Okay. So any real number less than -4, put in for x up here, right, or down here in the factored form, makes the left-hand side equal to 0, or makes the left-hand side negative. And so these numbers don't work. Real numbers less than -4 don't, or -3 don't work. Okay. And then in the interval from -3 to 0, you can use -1 as a test point. And when you put -1 in for x, right, you have negative times a negative times a positive. Which is equal to positive, right? So all these numbers between -3 and 0 make the left-hand side greater than 0. So those numbers work, okay, in our inequality. And then in the interval from 0 to 6, right, you can use 1 as your test point. And we put 1 in for x, right? You have positive times a negative times a positive. Which is negative, right? Positive times negative times positive is negative. And so none of those numbers work in our solution. Okay. And then lastly, we have all real numbers greater than 6. So I use 7 as a test point. I'm going to put 7 in for x. Positive times positive times positive. Which is positive. So any real number greater than 6 works. So our solution to this problem is all the real numbers from -3 to 0 plus all the real numbers greater than or equal to 6. Okie dokie?
Mm-hmm.
question.
Yeah.
Well, not about this, but can I ask you a question?
Yeah,
For when we did the homework, I think it was with the shifts, and you couldn't put it in as negative. If that were to come up on the test, and we put it down as like a negative shift, like to say that it was going to the left or the right.
well, the graph or the grid should be set up so that you can do a negative shift.
Yeah. So would we need to put it down like how we did for the homework, or put it down as like negative?
I'm not sure if I.
Do you remember when you showed us you pulled it up before class one time that you had to put it in? I'm pretty sure it was the
Yeah,
shift.
it was, what was it, 4.1? It was the last homework we did.
Yeah.
But
With the
it's just
number
phase-
two.
Yeah, it
phase-
was,
yeah,
it
the
was
phase
a
shifts.
transformation of the
Yeah.
sine and cosine.
So yeah. So there were a few of them that were negative, but you had to put it in as positive.
Oh, that was in the WebAssign.
Yeah.
Right.
So if it
Yeah.
were to be on a test and we put it down as negative.
Yeah, I would want you to do that.
Okay.
Yeah.
Cool.
Yeah, because that's what the text follow. I always follow the pattern of the text.
Okay.
Yeah.
That's alright. Yeah, I figured. That's what we learned in class.
Can we go over how to find the domain of a function under a root?
Square root.
Like
So-
an example in the review with for 3x plus 7.
Okay, so. So from the review, the function is what? F of x is equal to the square root
Yeah, 3x plus 7.
3x plus 7, okay? Now, we did study complex zeros of polynomial functions, okay? But when we're finding the domain of function, we're only interested in those values of x where the right-hand side equals a real number, okay? We're not interested in situations where the right-hand side equals a complex number, okay? So, you know that the square root of any negative number right, is imaginary, not a real number. So we're only interested in the real numbers that we can put in for x that make the value of the right-hand side a real number, okay? And so, square root of 0 is equal to 0, right? That's a real number. So, to find the domain for this function, we require the radicand, 3x plus 7, to be greater than or equal to 0. Okay? Now, that's just a linear inequality. And so when you solve for x, right, you subtract 7 from both sides, then you, excuse me, divide both sides by 3, if x is greater than or equal to minus 7/3. So that is the solution set in inequality notation. In interval notation, right, it's bracket minus 7/3 infinity. So you can't put a number in less than minus 7/3 in for x. Otherwise, the value of the radicand will be a negative number. And square root of a negative number is imaginary, not real. So, I mean, if I try to evaluate this at f of minus 3, right, at x equals minus 3, then I have the square root of 3 times minus 3 plus 7. Three times minus 3 is negative 9. Negative 9 plus 2 is minus 2. And square root of minus 2 is not a real number. Okay? So the numbers we put in for x have to make the right-hand side, the value of the right-hand side, a real number. Okay? Not an imaginary number. So we set the radicand greater than or equal to 0. Yes, ma'am.
I have a question about how to tell if a function is even, odd, or negative.
Okay. So,
There's an example in the note.
okay, so let me write out the definition, okay? So f of x is even if I replace x and f of x with minus x, and when I simplify, I get f of x, the original function now. F of x is an odd function if f of minus x is equal to the negative of the original function f of x. Okay, so I replace x with minus x, and when I simplify, I end up with the negative of the original function. And so you said you had an example?
Yeah, I got it wrong on one of the quizzes, and I want to see what I did wrong. It's f of x equals, x cubed, minus x cubed minus x.
All about, that's it?
No, it's x cubed minus x plus 4.
Plus 4. Okay. So that's the original function, right? So you put in, you evaluate the function at minus x. Alright, so f of minus x, you put in, replace x with minus x. And I can tell you it's going to be neither even nor odd because of this plus 4 out here. Okay. So, minus x cubed
Minus x.
is minus the negative of so minus x cubed is minus x times minus x times minus x, right?
Which is minus x.
Okay. And so negative times a negative times a negative is, and x times x times x is, so minus x quantity cubed is the negative of x cubed, right? And now we have minus x, which is, does this look like f of x? Does this look like the negative of f of x? Well, the negative of f of x, right, is the same as minus 1 times f of x. And minus 1 times f of x is minus 1 times x cubed minus x plus 4, right? Minus 1 times x cubed is minus x cubed. Minus 1 times minus x is plus x. And minus 1 times plus 4 is minus 4. That's what the negative of f of x looks like. Does this look like the negative of f of x? No. So we conclude f of x is neither even or odd.
Should we go over how to find a slant asymptote?
Do you have a particular function, or you just want me
Yeah,
to
I
make
do.
one up?
No, I have one. It's f of x is equal to 3x squared plus 5x minus 2 over x squared minus 4.
This graph of this rational function does not have a slant asymptote. The degree of the numerator is 2, and the degree of the denominator is 2.
Wouldn't it be 3 on the top?
What's that? The degree is determined by the largest power of x. And the largest power of x is 2. 3 is the leading coefficient. And 1 is in the numerator, and 1 is the leading coefficient denominator. So, in order for the graph of a rational function to have a slant asymptote, the degree of the numerator has to be 1 more than the denominator.
But if it, I guess not this equation then, how would you find its slant?
So what?
How do you find it if it's more?
You divide the numerator or the denominator into the numerator, usually by long division.
I have an example.
Okay.
It's f of x equals x squared minus 6x minus 7 over x minus 2.
Now this one, because this is the divisor is linear, you could actually use synthetic division in this case. Okay. So we'll do it both ways. Okay. So typically, right, if you have like a third degree, it's degree 3 in the numerator and only degree 2 in the degree 2 denominator. You have to do long division. Only in this case, where it's degree 2 over degree 1, could you use synthetic division. But we'll do the long division. So, x goes in x squared how many times? One.
Oh wait.
X times. So x squared divided by x
Oh yeah.
is equal to x, right?
Mhm.
So x goes in x squared x times, right? And then you gotta multiply x and x minus 2, which is equal to x squared minus 2x. And then you gotta subtract x squared minus 2x from the dividend, right? It's called the dividend. This is quotient, divisor. I think that's the dividend. Okay. And so when you distribute the minus sign, we end up with x squared minus x squared, which is 0, which is what we want. And then we're gonna have minus 6x plus 2x, which is minus 4x. Then how many times is x going to minus 4x?
Minus 4.
Minus 4 times. So then you gotta multiply minus 4 times x minus 2. Technically, we're done at this stage. And when we subtract minus 4x plus 8 from minus 4x minus 7, right, we end up with what? A remainder of minus 15. Okay. But what's important is the x minus 4. That's the equation of slant asymptote. Right? Slant asymptote is the equation of a straight line. So the quotient, right, this is the quotient, x minus 4. That's the equation of the slant asymptote. Right? The equation of a slant asymptote is the equation of a straight line. Now, to do this by synthetic division, right, the number that goes in the box is 2. And then the coefficients for the numerator are 1, minus 6, and minus 7. And so you know how to do synthetic division, right? Bring down the 1. 2 times 1 is 2. Minus 6 plus 2 is negative 4. 2 times negative 4 is negative 8. Right, negative 7 minus 8 is minus 15. That's the remainder. Right? And we said over here the remainder was minus 15. But these are the coefficients for the quotient. 1 goes with x, and minus 4 goes with x to the 0, which is 1. And so y is equal to 1 times x, which is x, and minus 4 times plus 1 is minus 4. So we get the equation of the slant asymptote. Okay.
I have a question.
Yeah.
Why isn't the 2 is from the 2 on the bottom, right?
Over here?
Yeah.
Yeah, because 2 is a 0 of the denominator.
So you wouldn't use the negative?
Because you have to set it equal to 0.
Oh, okay.
Yeah. Yeah, that's a good way of saying it.
So can I ask you a question with the first one I gave you, like on the top?
Mm-hmm.
How do you find like a hole in that graph?
Well, you got to factor the numerator and denominator. Okay. So the numerator, you guys gotta remember, I'm doing this live. I gotta factor this when I'm standing up here. So we got 3x times x. So it's gonna be plus and minus 1 is plus and minus 2. Oh, it's gonna be minus 1 plus 2. 3x squared. 6x minus 1x is 5x. Yep. And then this is the difference of x squared minus 4 is the difference of squares. It factors into x minus 2 times x plus 2. You see a common factor? So there's a hole at x equals minus 2.
So if there's a common factor, that means there's a hole.
Yep, in the numerator and denominator. So the coordinates, the y coordinate for this hole is found by putting in -2 into the reduced form. Right? So 3 times -2 minus 1 over -2 minus 2 is equal to what? -7 over -4, which is 7/4. So the coordinates for this hole are -2, 7/4.
So when you're graphing it, can you just use that like 3x minus 1 over x minus 2?
Well,
Or you have to use your
yeah. When you're graphing it, but you gotta be mindful there's a hole at -2 7/4 when you graph it.
Okay, but you can use the simplified version.
The reduced version, yeah.
If there's more than one common factor, does that mean there's more than one hole?
Yes. Yep. Yep. If there were 2 common factors in the numerator and denominator, there would be 2 holes in the graph. Yeah.
Could you go over how to find the inverse function?
Okay.
Like a function that has like ln in it.
Okay. Can you give me a
Yeah.
specific example?
Is it cool if it's just straight from the test?
Huh?
Is it cool if it's from the test?
Is it what?
Is it cool if it's from the test?
Yeah, it's cool
Okay.
if it's from the test. Yeah. Yeah.
So it says determine the inverse function for the function f of x equals ln. Or sorry, I'll give you a second.
What number is it?
8, I think, for exam 4. Let me just do. F of x
So f of x is equal to
ln, and then in parentheses x plus 4, and then minus 9.
Alright, so f of x is equal to the natural log of x plus 4 minus 9. Find the inverse function, right?
Mhm.
And there are 4 steps, same 4 steps in finding the inverse function of one-to-one function, right?
Mhm.
What's step number 1?
I'm not sure.
Replace f of x with
Y.
y. What's step number 2?
Switch x and y.
Switch x and y. What's step number 3? Solve for y. So we have to isolate y on one side of the equal sign, right? So first step, move that -9 to the left-hand side by addition. We have x plus 9 is equal to the natural log of y plus 4. Now, y is in the argument of the natural log function. So how do we get rid of that ln on the right-hand side? E. right? Since the left-hand side and right-hand side are equal, we can make them exponents on the number e, right? So we have e raised to the x plus 9 power is equal to e raised to the natural log of y plus 4 power, right? Natural exponential function, natural log functions are inverse functions of each other, right? They undo each other or cancel each other. And so we're left with e to the x plus 9 on the left is equal to y plus 4 on the right. And now we can subtract 4 from both sides. And I prefer to put the minus 4 out front. You don't have to. Just so you don't confuse it with the exponent on the number e. And you have minus 4 plus e to the x plus 9 power. Right? So, you subtract 4. What's the last step?
Negative for that.
Yeah, replace y with inverse function notation, right? So we have f inverse of x is equal to minus 4 plus e to the x plus 9 power. And we're done.
And then how do you find the domain and range from that?
So, so this is domain and range for the pardon?
Like, for that, the inverse.
For the inverse function, right? So, it would, the domain of the one-to-one function and the range of the inverse function are the same numbers, right? And we know how to find the domain of this log function, right? The domain the argument going into the natural log function has to be greater than 0. Right? You can't take the log of a negative number, and you can't take the log of 0. Right? It has to be positive. So you set the argument greater than 0, and then you solve for x, right? Solve that inequality for x. Subtract 4 from both sides. You have x is greater than negative 4. So inequality in interval notation, minus 4 to infinity.
That would be the range, right?
Right?
Yeah.
So the range is all the real numbers greater than minus 4. Right? We're talking about the y values. Okay. Now the domain, you can rationalize it one of two ways. The range for the natural log function is minus infinity to plus infinity. If you remember the graph of a natural log function. And the domain for natural exponential function is minus infinity to infinity. Okay. So just based on rational, just based on deductive reasoning, you can either argue the range for the natural log function is minus infinity to infinity, and so the domain of this function is minus infinity to infinity. Or you can argue that the domain for the natural exponential function is minus infinity to infinity. And that's what this domain is. Either way. The range of f of x and the domain of f inverse of x, right? Is all real numbers. So graphically, remember the natural log function when we graphed that way back when? Its graph looked like this, or like this, right? There's no minimum y value, there's no maximum y value, right? This is the graph of y equals the natural log of x. There's no minimum y value, there's no maximum y value. And that's why the range is minus infinity. The graph of the natural exponential function, conversely, looks like this. And its domain goes from minus infinity to plus infinity. So either way, right, you can argue that the domain is all real numbers. And this function, inverse function, is just a transformation of this function, right? So this function shifted to the left 9 units and then down 4, which doesn't affect the domain. Yes, ma'am.
Do like find the volume of an open rectangular box?
A volume of an open rectangular box.
Oh. Yeah, surface area of the box.
Yep, good question. So, can you read the problem to me?
Yeah, it says a company wants to construct an open rectangular box with a volume of 360 inches cubed and the length of the base 3 times the width.
Alright, so the volume is what now?
360 inches cubed.
And it has a rectangular bottom, right?
Yeah, open rectangular box.
And the bottom is 3 times the width?
The length is 3 times the width.
So if the width is x, then the length is 3 times x, right? And this is the bottom or base of the box, right? And we gotta write the surface area as a function of x.
Express the surface area of the box as a function of the width.
Doesn't give the name of the variable letter. Alright, so we'll use x, okay? So the volume is 360 cubic inches. And so x is the width, 3x is the length, and h is the height. Is it an open box or a closed box?
Open.
Open. Okay, so it has no top. Okay. So, well, we know what the surface area of the bottom is, right? It's just x times 3x, okay? But this box is going to have two sides of width x, right? So, right, this side of the box is going to have, this side of the box is going to have a width of x, and this side of the box is going to have a width of x. This side of the box is going to have a width of 3x, right? But they all have a height of h, okay? So two sides of the box will have a width of x and a height of h. And two sides will have a width of 3x and a height of h. And And we gotta write the surface area of the four sides and the bottom, right, as a function of x. Okay. Well, so the volume of this box, as we have now constructed it, right, is what, width times length times height, right? So the width is x, right? The length is 3x, and the height of the box is h, right? Well, the volume is fixed at 360 cubic inches. And x times 3x, or 3x times x, is 3x squared. And then times the height h, right? So we can solve for h. And we divide both sides by 3x squared. We have the height h is equal to 360 divided by 3x squared. 3 goes into 360 120 times. And so the height is equal to 120 divided by the width squared. Okay. Now the surface area, now we can tally up the surface area. Call it S of x, right? Surface area is a function of x. It equals the surface area of the bottom plus the two sides, right? Two sides of width x and the two sides of width 3x, right? So surface area of the bottom is x is 3x times x. The surface area for one of these sides, right, is h times x, or x times h, however you want to do it. Do it x times h. But there are two of them. So this is the surface area for the two thin, narrow sides. And then the surface area for this wide side, okay, is 3x times h, but there are two of them. So now we have the surface area for the bottom, the two narrow sides, and the two wide sides, okay? Well, 3x times x is 3x squared. H is equal to 120 over x squared, right? So I just replace h with 120 over x squared. 2 times 3x is 6x, and h again is 120 over x squared. So in this first term, right, 2 times 120 is 240. And x over x squared, x is canceled, I'm just left with x in the denominator. 6 times 120 is 720. And x over x squared, right, simplifies to 1 over x, right? And now these are like terms, right, that same denominator. Right, or I'm adding two fractions with the same denominator, so I can add the numerators. And I have s of x is equal to 3x squared plus plus 960 over X. And that's the surface area. Does that make sense? What we did? Does that match? Does that problem have an answer written down somewhere?
Oh, I don't have it on me, I reprinted out all the examples,
Okay.
so I don't have any down.
Okay.
If you wanna pull it up notes.
No, that's fine. Now, did you guys get a notification when I posted some practice problems? You did get the notification. I didn't send out an email because everybody says they get a notification whenever I post
We
it.
got the notification.
Okay.
Are we having another review session tomorrow on Friday? The Friday one's good.
The Friday one's 2 hours long, right?
Yeah.
Okay, cool.
When is the Friday one?
6 to 8. Yep. Thanks. So do you have any more questions or are you good for now?
I'll have them tomorrow.
Yeah, that's fine.
Yeah.
Yeah.
I have like a big final today, so like my brain's been like,
Yep, no, I understand.
but when that final's done, I will have lots of questions.
Yeah.
Yeah, I'll
Yeah.
probably plan more questions
Yeah.
tomorrow.
Well, you're 6 more people than I expected. So, yeah,
Thank you so much.
you're welcome. Yeah.